So this video would be about uh, writing an algorithm on BubbleSort. So I'm going to make a video series in which I'll be writing algorithms on all sorting. All sorting. I'll be writing Python programs on all sorting algorithms. So why will be I using Python? So basically, Python is one of the easiest language to implement the algorithms. Also, it will not like mess with you when it comes to syntax. So let's visualize bubble sort. How does it works? So basically it compares the two adjacent elements and it moves the greater one to the right side, and it does it for almost n passes, uh, like until all the elements are sorted. So I hope you now have understand the basics of it by seeing this uh, visualization. So let's move to the coding part. So this is for bubble sort. So first we need to define and declare an array. So we can basically give array of 2, 5, 7, 8, 2, 5, 8, 7, 1. So it is a smaller array, not much bigger. So now let's store the length of array using length function, passing the array 8. The length function will give us length of array. And now writing, like now going through the loop. So first we have to, as you can see here, we have to do total of n minus 1 passes for sorting. For n minus 1 times we have to compare these elements adjacently. So what I'll be doing, so in range of n. So n minus 1 you can do in other programming languages, but in Python n is okay. It will count from 0 to the nth element only. So for further you have to do like for j in range 0 to n minus I. So we will be subtracting I because on every successful pass we know that the last element would already be the largest one, so we don't want to compare it again and again, as that would waste the computing power. So that is the reason I am using 0 to n minus 1. By default it takes the increment by 1. If you want to add increment by 1, you can just add it like this. And now it is our job. So now we need to compare. So if a of j is greater than a of j plus 1, so if the previous element is greater than the next element, so that is how you compare it. So comparing adjacent elements here, so all we need to do is swap them both. So basically there are two options. You can either use a temporary variable, which would be like uh, substituting, like using temp and substituting a of j plus 1 in that, and then substituting a of j in a of j plus 1 we will substituting a of j. So this is totally one thing. So now we do basically this. This is also valid, but when you are using Python, it makes it more user friendly and easier to write with less lines of code. So the trick is you do a of j comma a of j plus 1 is equal to a of j plus 1 comma a of j. So in this way you are telling Python, I am giving you two sets of variable a and b. Give me b comma a. So swap them both. So this is much easier to write. And finally, after all this is over, we can just print out our sorted array, which is this one. So let me run this. So there is an error in this one. So for a in a of j to n minus I, let me do -1 for a second if we are having an error. Okay, so I got the error. Basically, it was saying us that it was going out of the index when I was doing n minus I, because on nth element it would just give me something like 5 minus 5, so 0. So maybe if the size of array is n, so I am taking the n from length, so there are 5 elements and I am doing like so it will just generate like 5 minus I, which would be again uh, greater than, so it would be giving me something out of index. So that was the reason, but we have successfully implemented the bubble sort.